In today's video, we're going to be talking about the quotient rule, which is a strategy we can use to solve derivatives. If we would like to find the derivative of one function f of x being divided by a second function g of x, we have to use the quotient rule, which is as follows. The quotient rule is g of x times f prime of x, which remember is just the derivative of our f function, aka our numerator, minus f of x times g prime of x divided by g of x squared. This is the quotient rule, and we can use this to solve any derivative where we have one function being divided by another. And we'll do 3 examples in today's video. Our first example will be we need to find the derivative of 3x divided by 7x squared. So first, let's establish what we're going to use as f of x and what we're going to use as g of x. And with the quotient rule, unlike the product rule, we do need to make sure that we have the right f of x and the correct g of x. The numerator will always be your f of x, so this one is f of x. And your denominator will always be g of x, so this one is g of x. 3x is f of x, and 7x squared is g of x. So now let's plug it into the quotient rule. So this is now equal to, put a big old division sign, g of x is just 7x squared, and we need to multiply that by f prime of x. In other words, we need to find the derivative of the numerator and then multiply that by 7x squared. Let's do that real quick over here in the top right corner. The derivative of 3x is just equal to 3. Using the power rule, we have a little invisible 1 here. We bring that to the front, multiply that by 3, and then subtract 1 here. What ends up happening is we multiply 3 by 1, which is just 3, and we take x to the 0th power, 1 minus 1 being 0, and anything to the 0th power is just 1. So the derivative is just 3. So we end up multiplying 7x squared by 3, and now we need to subtract f of x, which is just 3x, and then multiply that by g prime of x, which is the derivative of 7x squared. Let's find the derivative of 7x squared. Let's do that over here. d dx 7x squared. Once again, we can just use the power rule to solve this problem. Bring the 2 to the front, then subtract 1. So this is equal to 2 times 7x to the 2 minus 1 power. 2 minus 1 is just equal to 1. 2 times 7 is equal to 14. So this is equal to 14x, technically to the first power, but we don't have to write first power. Remember, anything to the first power is just itself, so we don't have to actually write the first power because it's implied. So then we just multiply 3x by 14x. And the bottom function is just whatever g of x is, in this case 7x squared, squared. So this is equal to 7x squared squared. Let's multiply all this stuff together and simplify where we can. So this then turns into 7x squared times 3. 7 times 3 is 21, and we just tack on the x squared. So 21x squared. 3 times 14 is 42. X times x is just x squared. So minus 42x squared. And on the bottom, 7x squared times itself would be 7 times 7, which is 49. And x squared times x squared would be x to the 4th. Simplifying this down, 21 minus 42 is equal to negative 21. That's still x squared, of course, divided by 49x to the 4th. There's 2 things we can do to finish simplifying this equation. Technically, this is the derivative, but we can make it a little bit simpler. First of all, we can cancel out this x and remove 2 of the powers of x here. And we also have a common factor on top and bottom. Negative 21 and 49 can both be divided by 7. So we can just divide both of these by 7, along with canceling out this x squared. So the final answer to this, the derivative of 3x divided by 7x squared, is negative 3 divided by 7x squared. And that's our derivative. Now, as a little disclaimer, I wouldn't recommend using the quotient rule to solve this problem specifically, but since this is a lesson about quotient rule, we're going to use it in this case. The next 2 examples will be ones that you have to solve with quotient rule, don't worry. In our second example, we want to find the derivative of 3x plus 2 on top, 3x plus 2, divided by 6x plus 7. Once again, let's establish which one of these is f of x and which one is g of x. The numerator is always f of x. So 3x plus 2 is f of x, and 6x plus 7, the denominator, is g of x. Let's solve our equation from here. Once again, we just have to use the quotient rule to solve. Let's put a big old division sign here. First, we need to put in g of x, which is just 6x plus 7. And then we need to multiply that by f prime of x. So once again, we need to find the derivative of this function. We can do that over here. And just like in our last example, we need to multiply that g of x times f prime of x. So let's find f prime of x, in other words, the derivative of the numerator. And we can just do that down here. So the derivative of 3x plus 2 can be split by the addition sign. It's one of the properties of derivatives. So we can solve for each of these derivatives individually and then combine them to find our new derivative. The derivative of a constant, such as 2 here, is always 0, so this will just be 0. And the derivative of 3x, just like up there, is just 3. So 6x plus 7 times 3 is the first part of our equation. Now we need to subtract f of x, which is 3x plus 2, being multiplied by g prime of x. And we'll do that down here as well. The derivative of 6x plus 7, our denominator, can be solved the same way as this one. We can split these two by the addition sign, then find these derivatives individually, combine them to get the new derivative. So the derivative of a constant is still 0, and just like in this example and that example, the derivative of 6x is just 6. If you have a function that's just a variable with one coefficient attached to it and no powers, the derivative of that function will always just be whatever the coefficient is. So this is just 6. And then on the bottom, we just plug in g of x squared, which would be 6x plus 7 squared. We have a lot of simplifying to do, so let's continue doing that. In fact, I'm going to erase this so I have enough room. So 3 times 6x plus 7 is 6x times 3 plus 7 times 3. 6x times 3 is just equal to 18x. 7 times 3 is equal to 21. And now we have to subtract. 6 times 3x is equal to 18x minus 18x. And then we multiply 2 times 6, which is just 12. And then on bottom, we have, and remember, whenever you square something in parentheses, you don't just square 6x and 7. You multiply 6x plus 7 times 6x plus 7. So on bottom, we have 6x plus 7 times 6x plus 7. So on top, we can simplify some things. This 18x and 18x cancel out. 21 minus 12 is equal to 9. And since we have no x's in the numerator anymore, there's not really any reason to FOIL this all out. So we're just going to leave this as 6x plus 7 squared. So now we just have 9 divided by 6x plus 7 squared, and that is equal to the derivative. We're going to do one more example. Our last example will be finding the derivative of 3x minus 1 on top divided by x to the fourth plus 2. What is this derivative? Well, once again, let's establish what f of x and g of x are. F of x is always our numerator, so that would be 3x minus 1, and g of x is always our denominator, which is x to the fourth plus 2. Wow, I wrote that very poorly. Hold on. X to the fourth plus 2. They kind of got combined. I think that looks a little better. So let's plug that into our quotient rule formula. This is now equal to, big old division sign, g of x is just x to the fourth plus 2. So to find f prime of x, we just need to find the derivative of 3x minus 1. The derivative of 3x minus 1 is equal to 3, just like before. The derivative of a constant is just equal to 0. And the derivative of a coefficient multiplied by just x with no power is just the coefficient. So this is just 3. Now we just have to subtract f of x, which is 3x minus 1, and multiply that by the derivative of x to the fourth plus 2. Let's solve that down here real quick. The derivative of x to the fourth plus 2 can be split by addition. So let's find these separate derivatives and then combine them at the end. The derivative of a constant is just 0, so we don't have to worry about that. Using the power rule, we can find the derivative of x to the fourth is equal to 4, that's the power we brought to the front, times x to the 4 minus first power, which is equal to 4x cubed. So now we just multiply 3x minus 1 times 4x cubed, as so. And on bottom, we just have to plug in g of x squared. In this case, it's x to the fourth plus 2 squared. Let's FOIL out this function and see if we can cancel anything out. And I'm going to erase this here just so I have enough room. X to the fourth times 3 is equal to 3x to the fourth. 2 times 3 is just 6. Or 4x cubed times negative 3x is equal to negative 12x to the fourth. And 1 times 4x cubed is just equal to positive 4x cubed. Distributing the negative, negative times negative 1 is just 1 times 4x cubed is just 4x cubed. And then we're not going to FOIL this out on bottom because this is just going to look worse than in its simplified form here. So this is just x to the fourth plus 2 squared. Let's simplify the numerator to finish up our quotient rule derivative. There's only one thing to simplify. 3x to the fourth and negative 12x to the fourth can combine. So the final answer to this quotient rule problem is negative 9x to the fourth plus 4x cubed plus 6 divided by x to the fourth plus 2 squared. And that is the derivative of 3x minus 1 divided by x to the fourth plus 2 using the quotient rule to find it. I hope you guys found this video useful. If you did, consider subscribing, and if you want more Calculus 1 help and more details on stuff such as the product rule, the chain rule, and the power rule, consider clicking the playlist here or the info cards scattered throughout this video. I'll see you guys in the next lesson.